All right, so first up, I'm going to be gone tomorrow for a good reason. So tomorrow is still, hopefully, if you use this time well, third hour really did. It's going to be just to continue to work. There's a lot to work on. So yesterday I gave you review number 1. Those of you who are in my elk time, you'll easily finish that today unless you didn't use that time, and you'll be moving into 2. There's a little bit of a danger. I had 2 people last hour who came into elk time done with 1, started 2, and so they were well into 2 when they left today, and they have all hour tomorrow. That's kind of dangerous because then you don't interact with it again until you test on Tuesday. So I wouldn't go that fast. I would just kind of parcel it out between today, tomorrow, and maybe use Monday to check it or something, like bring the key. But I would on Monday because I won't see you again until you test. The second review, though, isn't as long as it looks. So those of you who grabbed this second one, the first 2 pages, I tested you on that content last chapter. So I get these from multiple sources, and we've already tested on 1 through 13. So if you could carefully just remove it and keep the staple intact. This one starts with 14 with particle motion. All right, so the number 14 is the particle moving. It gives the velocity. So take those first 2 off. Maybe write review number 2 on the top of it so you know it's the second one. And then today we're going to go through, I got good data from AP Classroom. It was good for me to see the ones you're getting wrong because a lot of them are easy to fix. So, we're going to go over the 5 most missed. It takes us about a little under 10 minutes because none of them are labor intensive. You got those kind right. The long ones that were kind of standard, but they took a while, we got those right. It was short ones with a twist. So I was actually kind of sweet. This won't take me very long. But I want to talk about dealing with the twists because that's super important. Both the reviews are due before your test. Usually I just collect 1. The other's optional. For this chapter, they're both going to go in my grade book. And then also too, there was this extra credit. It's the YouTube calculus live on Monday nights. Last Monday was on related rates, so I thought, well, that'd be good to throw that out there. Do it or not do it, it's 2 test points, which doesn't seem like a lot, but as we do more of them, so next chapter I know there's one on optimization I'm going to put out there for extra credit. Those can accumulate way more than the homework ones can. All right, so any questions on what you're doing tomorrow? Basically, you're just going to keep working. I wouldn't waste that whole time. Like if you wasted the whole elk time, you waste today's work time, and tomorrow's whole, you're going to be at home and your parents are going to be like, that's a lot to do. And then you're going to honestly say, yeah, but she gave us a ton of time and I didn't do it. All right. So we're going to take a look at this one. This is easy to fix. It was missed by a lot. I tried to, after I started screenshotting, I screenshot how many got right and wrong. That's why the ones towards the bottom, you can actually see how many people got it right and wrong. But I didn't do that on this one. But this was the most missed one, and it's so easy to fix. All right? Because it's really not calculus. This is a concept you've known how to do for a long time. When you're in a car, your velocity is your speed, correct? And if I were to send you on a 200-mile road trip, and it took you, let's say, 5 hours, right? Your average speed, wouldn't you just divide that and label it miles per hour? Right? What is 200 divided by 5? 40 miles per hour. You're going pretty slow. That's your average. It's just how far you went in miles or feet divided by how long it took you. So this one isn't a calculus problem. The physics people are probably the ones who got it right because when they learn velocity, they write it as change in position over change in time in physics. That looks familiar, right, by physics people? And you only find average in physics because you need calculus and derivatives to do at this instant. So when it says what's the average velocity, you just need to know where was I at the end. That would be your position. Where was I at the beginning? This will give you how far you've traveled. So that's a position, it's how far you've gone, but you've done it over how many time units? 3. That's all it was. There was no derivative taken, nothing like that at all. All you had to do was put a 3 in here, square it, multiply by -5. That's a 0. Computation is super easy, it's just 0. over 3, and I get negative 15. I actually think had I put this question up day 1 of school, more of you would have gotten it right. Then, because it's not calculus, you've been good. Oh, velocity, speed, how far I go. You know what I mean? It's the calculus higher level that's messed with the easy kind. So in calculus, we do it at a given instant, but you still need to know how to do averages. This guy right here, too, computationally is really easy. We're doing an approximation for a tangent line, correct? We need a point. They gave you one, and then I told you there was a little prime symbol in there when you took it. And we need our slope, which is our derivative, which is 5. I know you guys know how to do this, so that's why I'm going really fast, because this is super easy to get an equation for that tangent line to the curve. It was this directions right here. You're used to saying approximate the y value when x is really close to 3. So they'll say use it to approximate like 3.1 or 2.9, and you just plug it in right there, right? But this one didn't say that. It says to find an approximation for a 0 of f. It doesn't say when x is 0, it says a 0 of f. So you have to go back to your other math classes. When you would go graph a function and your math teacher would say give the zeros, what would you actually give for your answer? Yeah, the intercepts. And at the intercepts, x's aren't 0. What's 0? Y's. So you were supposed to put a 0 in for y. It was this word. Not that the math got harder. So that this is actually good when I look at the data. It's not the calculus that was stumping you, is when any wording was different. So that right there. And then if you solved it, I'm not going to solve that because that's 7th grade math to solve it. So you get x equals, I think you get 13/5. All right, so our next one is number 8. There's nothing in here you don't know how to do, but I know exactly why it's wrong. So let's go take a look. This is position. I'm looking for velocity at the instant when the velocity is 0. So I'm trying to find what t value would give me a velocity of 0. How do you go from position to velocity? Take a derivative. What kind of a rule is needed to take that derivative? Product. Yeah, it's a product of functions. They're not hard derivatives to take, but they do have the t in it, so you got to be a little bit careful. But my independent variable is t, so I don't even need chain rule or anything. So this one would be first function. Let's go write it down. D second, we know the derivative of sine is cosine. Yeah, not a hard derivative at all. Plus second. All right. And then what's the derivative of e to the t? E to the t. What's the derivative of e to the negative t? Negative, yep, we go e to the u times its derivative, which would be negative 1. So that'd be a minus 12 that goes right there. We good so far? I'm supposed to do it when the velocity is 0. And I told you if you don't have a calculator, which this one doesn't have the little calculator icon next to it, it will always what? Add, factor and factor easily. Yeah, so we're going to factor out a 12. And I'm going to factor out an e to the negative t. And that's going to leave me with a cosine t minus, because I have that, the sine t. All right. So this is where I think it got people. The solving of it is not like a nice polynomial like x squared minus 2x plus whatever. But it doesn't matter because for a product t equals 0, one of the two pieces, that can't be 0. Should make sense why, correct? That can't be 0. This can be, right, only when cosine equals sine. So you have to, that's where I think, I mean, I don't think any of you probably when you're doing this didn't know to use the product rule or didn't know that you needed the velocity to be 0. You knew you needed to factor, you unanimously said it. It's the trig part of this one. So again, around the circle there are 2 places where cosine, the x's, equals sine, the y's, correct? Where are they? Pi over 4. Yep, they are both root 2 over 2, root 2 over 2 at pi 4. Where's the other place? Not here, correct? Why not? Yeah, cosine's negative, sine's positive. Some of you did circle that, though. You can see, I think how many people are on that one? I think 3 people got there and they knew it was a pi fourths, but they didn't know which one. So I think that would be that. Those 3. I'm worried about those 8 and these 7, like where those came from. So it says at which the velocity is first equal to. So even over here, they're both negative and negative. It says the first time, which would be the lower time, which would be at pi fourths. All right. So that one I think was the trig. Right. All right. And the reason I think it's the trig is because another most missed was this one and what's also in it. Trig. I don't think it's the motion concept or the calculus part of it, so that's why I said these are kind of encouraging because it's easy to fix. So this one says I need the particle to be at rest. What does that mean? Velocity again must equal what? 0. So I'm given the position, so we know to take the derivative. My guess is you all need to do that. And we know the derivative of sine is, cosine. And then what's the derivative of the inside function? 2 pi. Yeah, it'd be the derivative with time being my independent variable of 2 pi t, but just so you can see it, it's 2 pi, and it would be dt dt. All right, so 2 pi. There's my first one. Plus, and what's the derivative of 2 pi t? 2 pi. I need this to equal 0, so I need to factor. What factors out of both of them? 2 pi. So I'm going to factor that out. It'll leave a cosine 2 pi t minus, plus, what? There we go. There's nothing about it. It was kind of encouraging that you got what I thought was the hard ones right, because these are fast and easy to fix, but I want you to be able to, because these are easy points to earn back. So when I solve this can't be 0. It's 6-ish. So that means I need this chunk to be 0. So cosine of 2 pi t has to equal -1. I kind of think a lot of you might have gotten that far. But you have to figure out, well, what t value, because that's what I'm looking for, will cause that to happen. So first of all, let's just pretend we don't know what this is. I'm going to call that argument in there theta. Cosine of some angle is -1, correct? Cosine of what is -1? Pi, right there, correct? So I need this stuff in here, that chunk or the argument of the cosine, to actually be pi, which means I need 2 pi t to be pi. You're nodding, right? It does make sense when somebody else does it, right? You're probably going, why did we get these wrong? I was kind of thinking the same thing, but I'm like, well, they're easy to fix. So my t would have to equal what? 1/2, and there were 17. But 11 didn't, and I think it was the trig part of it. All right? And then, number 15, or second to the last one, there's no work to show. So this one, I think, was reading it too quickly. Because I think you were thinking, oh, I need to go from the original to the second derivative, and I think you saw millimeters and you saw minutes, so you knew it needed to be 2 pers, because every derivative is a per. So 17 of us chose millimeters per minute, because he did, I think he didn't read it really carefully. In this problem, it's not particle motion, it's not something moving, millimeters, as time goes by. This is, it says, giving you the time out as what is changing. The amount of, do you know what a catalyst is? What is it, Eli? Something that speeds up a reaction, right? So they're saying this catalyst that I put in is going to determine, so this is my independent variable. The catalyst is affecting how much time. It's not the time affecting how fast we're going. Does that make sense? So if you were to graph these, if you were to think of y equals f of x, just so you can kind of go, because this is an easy one to fix, there's no math in it. It's just conceptual. We would go y, whoops, sorry, that's not true. We would go x and y, correct? And you would do change in y over change in x. This label is the label of the top of the fraction. So when I have mine over here being a going in and t going out, correct? These are kind of the y's are on top of the fraction. What is t measured in? I'm putting that in, it would be minutes, correct? Going first. Per what? Millimeter of catalyst, and then I do it again per millimeter of catalyst. So 11 of each, nobody picked these. What does that tell me? You know what a second derivative means, correct? Which is good. But read the problem carefully, because in the context of this problem, you're used to a b-particle motion and they mess with you. And it happens a lot. Another easy one to fix. All right? This one's the easiest related rate of the whole chapter. But look how many people got it wrong. Guess why? You want to know why? Say why? Nope, there's no trick in here. The other two I think were trick. It's because we never did one like this anywhere in the notes, or anywhere online, or anywhere in the homework. So it's new, but it doesn't change the process. So let's go take a look. X and Y are functions of t. Let's say t stands for time. It doesn't say that, but let's suppose. Oh, it does say time. All right? And the sum of x and y. Well, we know what sum means. And it says the sum of x and twice y is equal some constant. You could put one here if you want to make it up, but I'm just going to use c for. That's what they're telling you. That's your equation. That's way easier than volume equals 1/3 pi r squared h, or that weird one we had yesterday with the surface area, the hemispherical liquid receptacle, right? That's way easier to take the derivative of. And how do I know I need to take the derivative? Because it says the relationship between the rate of change of x. That's dx dt, correct? And the rate of change of y with respect. They're asking me to find how dx dt and dy dt are related, which means I just need to go over here and take the derivative of both sides. The easiest one we've had this chapter, right? What is dx dt? Well, that's pretty easy, right? What is the derivative of 2y? 2, then what? dy dt. And regardless of the constant, what's the derivative of any constant? See, isn't that easier than any one we've done? Well, the rectangle day was pretty easy when we did the rectangles, but you've just never had one before. I don't see it up here explicitly, but isn't this just a little manipulation of it, right? So that's easy to fix. So I have a love-hate relationship with the ones you got wrong. They're easy to fix, which means you're getting the long, hard ones correct. But I think we still are struggling with when it's not one that's really similar to one we've done before. So we'll get that figured out by May. We're done. All right. So the rest of the hour, how long did that?